multiplies to 1/2, and it does. So your scale factor for perimeter is going to be the same scale factor as your shapes, but you take that scale factor and square it, and that's going to give you your scale factor for area. All right, now we have two rectangles, 8 feet long and 6 feet long. So we're going to go ahead and draw our rectangles and label them. And then the rectangle, it's similar to a rectangle with the width of 18 feet. So you'll notice I labeled the wrong rectangle. So we're going to go ahead and make this one the 6 and this one the 8, because the similar rectangle has a width of 18 feet. So now I know small and large. So we're going to do corresponding parts. We're trying to find x. So we're going to take the small length, which is 8, over the large length, which is x, because you're always going to take your variable first. And then take the small width, which is 6, over the large width, which is 18. Now we're going to go ahead and butterfly. Remember that you butterfly the wing first with the variable. So we're going to butterfly. It's going to be 6x is equal to 144. Divide by 6, divide by 6. X is equal to 24 feet. Now remember, for algebra purposes, make sure your equal signs are lined up and that I can see all of the steps. All right, for problem number 4, you're going to draw two rectangles. The first rectangle, DEFG, has a perimeter of 30. So you're going to put your P equals 30 inside, that's your perimeter, and it has a width of 6 centimeters. The second rectangle that you're going to draw, JKLM, has a perimeter of 120, and we don't know what the width is, so that's going to be X. So remember that if we have one figure that we don't have any of the measurements, the lengths or the widths, we have to use scale factor in order to find it. So the first thing that we're going to do is figure out what the scale factor is. So the scale factor is going to be small over large. So we're going to take the perimeter of the small, which is 30, and put it over the perimeter of the large, which is 120. Okay, when we simplify that, and remember you can use your calculator on the test, so make sure that you're using your calculator now to double check. When we simplify that, that means that our scale factor is 1/4. Now we're ready to set up the proportion to find x. So we're going to take 6, which is the small width, over x, which is the large width that we're looking for, and we're going to set it equal to the scale factor, which is 1/4. We're going to go ahead and butterfly. So we're going to have x is equal to 24 centimeters. So notice that the scale factor for the sides is the same as the scale factor for perimeter. All right, now let's go ahead and draw two triangles. You're going to draw triangle ABC, label it with its lengths, and go ahead and draw triangle LMN and label its lengths. The figures are similar, and we're just trying to find the missing side. So what we're going to do is we're going to use corresponding parts. So if we're looking for x, we have to find the corresponding part on ABC, and that's going to be 12. Remember your prayer partners when you're setting up your proportion. So it's going to be small over large, so it's 12 over x. And then I can use any pair of corresponding sides that I want. So we're going to go ahead and use 6 over 10.5. Okay, we're going to go ahead and butterfly. So it's going to be 6x is equal to 126. Divide by 6, divide by 6. X is equal to 21 inches. Now you're going to go ahead and set up your drawings for this. A 15-foot pole casts a 9-foot shadow. So this pole is 15 feet and the shadow is 9. Find the height of the tree. So we don't know how tall the tree is. And it casts a shadow of 6 feet. Now remember, all we're going to do is use corresponding parts, and we're going to set up our proportion. Remember prayer partner, so the smaller one's going to go on top. So it's going to be x, which is what we're looking for, over 15 is equal to 6 over 9. Now what we're going to do is go ahead and butterfly. So we're going to have 9x is equal to, looks like 90. Divide by 9, x is equal to 10. So our tree is 10 feet tall. Now what we're going to do is prove that these triangles